day 6. This took him 10 minutes.
Okay, rookie. Might be a good... I don't know, it could be a good score, though. This one's quite hard.
Yeah.
Especially the second part is difficult. Be interesting. I think his answer could well be unintelligible.
He does. His code is quite nice, though. Like, it's not actually hard to read.
The answers aren't as abhorrent as I thought they would be.
Yeah.
Like, it's not how I would write them.
I'm going to take a second.
What's interesting is you need to adjust your approach. So the first days, he just wants to look at it, inhale it, and just try and solve it. But by day 6, he's like, look...
I need to take a bit longer here.
Because mistakes in comprehension are going to cost him more time.
Yes.
Because he's not going to be able to solve it in like 2 minutes. So it's not...
Yep, that's a very fair point.
It's interesting how you have to adapt. The leaderboard's also completely changed. I don't know if you've noticed.
No, I don't really look at it.
Yeah, it's completely... The same characters are at the top, to be fair, but there are some people that have obviously done better as they've got harder.
Oh, interesting.
Yeah, so the people that are now winning weren't winning in week 1, like the first few weeks. Because I guess the first few weeks are just about, can you solve it in like 2 minutes?
Yeah. I also love how the fact that he's just double checking that he remembers how to read from a file, like everybody does, because nobody knows how to do it.
Jonathan's only human.
yeah. He's like, is it dot read lines? Yeah, it's dot read lines.
Okay, what the...
Oh, hang on. So
he's done what he's doing it the way you did it. So he's taken the left-hand side things and assigning E, I don't know. So
Easy is defined at the top as a map.
The map.
Yeah, you're right. So he's got the children as the values, the parents as the keys.
I find that syntax particularly strange, but okay.
It's indexing into a map like a key. So it's the way you do it in KDB, actually. Oh. Easy.
Oh, God. He kind of writes backwards a lot.
Yeah, it's interesting to see how his brain works, because I'm a bit lost here.
Yeah, I'm quite lost too. Okay.
So for
X in E...
So is E the keys or the values? Key error. Can't do that append, which is... okay, yeah. Oh, dot. Strip the new line. Can't add it. Okay. We're going to have to go back to that if he gets it right. Jesus. Alright, should we just have a quick look?
Yeah, let's have a butcher's.
So he's going to fix it here and then we'll pause. So I think that's the final answer. So he's obviously having issues with his map having nothing instead of an empty array, because he's had to fix it here and he had to do this here. I assume this is get X and this is a default if it doesn't exist.
Right.
I'm assuming that's what that syntax is.
So he said get A, B if A is not in E. So if it's not already been inserted.
Where are we looking?
Yeah. If A is not in E,
then create an empty list for that key. Otherwise, you can... So obviously, if it's not an empty list, you can't do the append, which was the first error he was getting. Right. So this builds the thing that builds the...
The first time you've seen a thing... So what is he building here?
Yeah, so this is building the same dictionary as I was building. So on the left, the A is the left-hand element, and the B is the right-hand element. So it's the planets on the left, and then as the keys, and the values are the children of that planet.
Yeah.
So that's what he's building there.
Yeah.
I think that makes sense.
Yeah.
And then he's saying for X in E, which I'm assuming is the values or the keys. I'm assuming the values, because that's a map. So what you getting? What does that give you in Python? Probably the values.
It must be the values, yeah.
And then he's saying keep track of the orbits with this F function. So this is then how he's calculating his orbit.
Maybe it's the keys. I think it must be the key, actually, looking at this code now.
But in the other way, he had to do like E.keys. But maybe this, I don't know.
I don't know. It must be the key though, because he's about to call e.get with x there.
Yeah.
So that makes me think it is the key.
Or it's, yeah, because otherwise it would have to somehow also flatten the arrays. It wouldn't iterate properly, right?
Yes.
Yeah. Okay, so for the children of x, recurs down. So then he's basically doing it the same way I did it, right? He is saying get the children of that element, and then add all of the children, the path of all the children plus myself.
That's very clever. His recursion.
This is a. I was confused by this. I was like, he's adding and then adding again, but yeah, I didn't actually notice that this F here was the recursion back into this.
What I'm really noticing is that I'm so used to using higher order functional programming that this stuff with like plus equals and assigning things is really weird for me. It's probably really normal to most programmers, but I haven't done it for about 4 or 5 years, so it's kind of like really strange.
Yeah, it's very traditional, I guess, is probably
yeah.
That.
But yeah, okay.
You alright with that?
Yeah, I think so. And the one
to count yourself, I guess.
Count yourself, yeah.
Yeah.
Yeah, it's interesting. Well, he could have said answer plus equals fy plus 1.
Yeah.
Which would have been, I think, better. But
which probably goes to show the way he's thinking about it.
Yeah.
All right, should we?
That was rapid though, and I had no comprehension of what he'd done until he stopped it. Really,
well, it's because of this defer to this F, and then it's like, well, hang on, what the hell is
he wrote it backwards, didn't he?
Yeah,
in a weird way whilst he was thinking, and it was hard to follow.
Yeah,
but yeah.
Okay, let's power on.
Let's see success again.
Let's see the rank.
Success.
Rank 8.
Rank 8. This is pretty involved. So he's got to go from U to Santa. How many orbit changes?
Yeah. Orbit transfers, yeah. Orbital transfers, yeah.
Yeah.
Bit of reading time.
There are lots of things that are shocking about these videos, but I think how quickly he reads it is really part of that for me. I mean, how quickly...
But it's the reading and comprehension as well, right?
Yeah, it's nuts. This is quite complicated. It is taking a bit of time. What?
Assume that's an error. While Q. Okay, so he's got a Q, has he now? Oh, a DQ, which is a...
Changed his mind on the structure. Don't really know what DQ is, I'm not going to lie. But
it's a double-ended Q, so you can pop from either side, I think.
Oh, okay.
That's why he's had to do pop left, to say pop from the left-hand side of the Q rather than pop right, I see.
Goodness me.
What has happened here? I don't understand while Q. I'm still stuck there.
While Q, yeah, that's mad. Maybe he's going to change that though. Maybe that returns false when it's empty.
Descent.
Windows update.
That's the audible bell.
Very hard on himself.
Yeah,
it's more obvious when you're watching. It's a gift that keeps giving for him, to be honest.
So he's done the parents. He's reversed. He's made another list. Oh, in the same diction map, he's done it the other way to give you the parents from the children.
Yeah.
Whoa! What? I didn't think he was anywhere near rank 5. Do we want to have a go?
What
back?
the? How? Wait, we'll show us the program again in a second. How? So he's calculated it,
I don't.
factored in the off by one, and then manually subtracted the off by one in his mind, which I mean is not rocket science, but it's pretty mental that he managed to get that right. If he gets that wrong, he's probably going to rank 20, 30, 50 positions lower because he'll have to wait, which is crazy.
Jeez.
Like for every node, just add up the size of the subtrees we did at every node. Right? That is.
So he's done it like you.
Yeah.
Here the subtree
Maybe.
5 things. Because. Yeah, I just look at the size of E. 5 things. Actually, I guess the size of the subtree minus 1 because typically for the subtree you have.
I mean, there's another great point there. He's reading it back, not really understanding what he's just done.
No.
Because he's like, is it E? Is it -1? Is it? I don't know.
I'm with you. My read on how far he was from solving it was he was at least another 30 seconds away.
Yeah.
Like
He
easily.
didn't have it, yeah.
Yeah, he didn't have it in my mind, and he's just solved it. Like he's just like, that's the answer. He's like one step ahead of me watching him.
Yeah.
Your time just by sort of going bottom up. But I did n squared. It was a little easier to do, and it works fine.
Big O notation.
He just knows the big O in his 4 seconds of comprehension. What the heck?
Part 2 then.
And part 2
Here we go.
is just distance on a tree. So, yeah, they just give you two.
Is that a known problem then?
Maybe.
Distance between them. They say not the distance between them, between the objects they're orbiting, but that's just the distance between them -2.
Yeah.
Right.
So this is just.
Should we have a look?
Yeah.
Right, we'll pause it and have a look. So, I was confused with the DQ.
He's built a different thing. Maybe we should start there. He added that late on, which made that particularly hard to follow. So
Then he added this line as well, late as well.
yeah, and that line's like really important because now what he is completely different. It's everything.
It's every relationship between every element, I think.
It's
Parent
everything
and child.
forwards and then everything backwards.
Yeah, that's my understanding.
Yeah. So if you've got a relationship A bracket B, then you'll get AB and BA.
Yes.
Yeah.
Yes.
So it's everything in there twice, basically.
So he has a D, which is his empty map, and now as well as E from before. He's got Q, which is a DQ, and he's appended to it U0. So he's going to use that thing on the right, I think, is his counter.
Right. Goodness me.
So
Yeah.
then he's saying, whilst there's something in there,
Yeah. So that's a tuple. So
tuple, yeah, so pop left, and you've got your X, which is U, and your D, which is 0. I don't see how this... Anyway, so if X is in D, you just ignore it. D is currently empty, so
Yeah.
that would fail. And then you're setting D of U...
Wait, does continue go round the while? I don't use continue.
Yeah. So, versus break, which would get you out of it. I assume they have that.
Right.
So then it's setting into the D map U0. And then you're saying for each of the children or parents, depending where you are, right?
Yeah.
So looking for E for U. For each of those, append the child with its distance.
+1.
With the original distance +1. So he's gone both ways. So I think he's actually going up, isn't he? So he's starting at U, which is at the tree, and he's saying, I'm going to work my way up and then work my way back down to Santa, I think.
I think it's more basic than that. He's saying, I'm at U. Which ones... Wait, does he say anywhere? He says, if X is in D...
So if I've already seen it before, I don't care.
Yeah. What does he add to D later? It's really weird.
So he
how
adds
this
one and he
reads.
appends it, right? So he's saying, I'm at U. So say it goes A, B, U. He's saying, right, U is 0 because it's the child. And then he's saying, I need to get the parents or children of U. There's only a parent in this case.
Yeah.
Then it's saying, for Y in the parent, add into that B and 1. And then we go around again.
And he's added... And what's the D bit? So he's added...
So this is him tracking the distance for each element, right?
Right.
So then he's going to say D, so then it'll go round, and then X and D will be B1.
Yeah.
I haven't seen B before, so he's going to set the B key in D to be 1.
Yeah.
And then... So it's the first time you see that child, basically. The first time you see that element, that's your distance from you.
Yeah.
So it does means that you don't overwrite it with a bigger distance or a smaller distance.
Yeah.
So then, and then he gets the parents again. I think it basically means he doesn't have to because he's done it this way. Because what I would have done is probably got rid of the giving me the child relationship, but he needs them both because he gets up to a certain level, he needs to come back down again. So I think doing the continue means he can just still traverse the whole tree, and somehow it will give you just the right route, which I don't really understand.
What I don't understand here is how it gets him the minimum.
Yeah.
What's particularly strange as well is that I would have expected in the way he's coded this in the wild to have a condition that's like, if I get to Santa, then just stop. But he doesn't have that at all.
Yeah, so he's going through the entire tree, and not stopping
never stopping
until the tree is exhausted,
and then he's just building up. How long?
The first time, how long it took to see it the first time each planet. That's what that D is. What was the distance from you the first time I saw that element?
Yeah, because if you see it again, then it
just gets this. It hits this continue. Yeah.
So that stops it from like accidentally traveling back on himself, which is pretty clever. So he's basically saying the first time I see something, otherwise just don't.
Yeah.
And so then and then with the Q append, he's basically saying for Y in EX. So for
child or parent.
Yeah. I mean, there is no child or parent in a graph really. There's just like, well, I guess there's sort of it. There's no sense of what's at the top or bottom. I suppose.
No, I guess I'm thinking of it as a tree because it sort of reads that way. But yeah, you're right actually.
Yeah, which is why he's added links both ways. He's saying every way I can go from where I currently am.
Yeah.
Let's add that on. And so then those are now in the queue. And then so it's interesting to see someone solve this with a queue.
Yeah.
Because this is, I mean, it's not recursive, but it kind of is because the queue is what would be one of the recursive parameters.
Yeah, and then so in that example I gave where you got A, B, and U, the next time he goes around to B, one of the children would be U, but because actually in this case I don't know. Oh yeah, in that case it would track that U was one away from B, I think. But then if you go up to A, it won't go back down to B because B's already in the list, then it'll just continue away. So it doesn't redescend the tree, I think.
It's pretty clever how he's kept track of ones he's already seen and then just been like, if I've already seen it, not interested.
Quite nice.
It's actually, again, it's quite short and minimal. It's what's annoying about these is that he solved this, I think I don't know if it's clearer than the way that like yours is never going to be clear to another human, to anyone that doesn't know KDB, but say the way I solved it, I think in some ways it's definitely less code. Like we looked at the other day about how I did mine. It's pretty interesting. What did this get him 8th?
Yeah, I think so.
Gosh.
Right, should we have a listen to what he's got to say for it?
Yeah.
Simplest graph algorithms. So for 2, it's easiest to make both the edges bidirectional, so that you can go from a thing to the thing that is orbiting, not just from something to something that's orbiting it. But as you can go backwards, you can go right to left on this graph, which is the thing that you're allowed to do. So the way that graphic search works is you just we're going to keep track.
I hadn't realised breadth-first search actually.
Yes.
So we're going to start right with you. That's what they told us to do. Well, we're going to start with the same difference.
It feels a bit like he's gone, this is breadth first search, and coded breadth first search.
And it happens to give you the right answer.
Yeah.
And we're also going to keep track of sort of the things that we're currently exploring. So every time you explore a new vertex, you grab it. If you've already seen it, then you can ignore it because there was a faster path to this. Actually, for a tree, this doesn't happen. There's unique paths between all two.
He knows he's using a lot of terminology like vertex that means that this is fresh in his mind.
So you mark off that's the distance, and then for all of its children, right, if you get to this node in d distance, then you get to any of its children in d plus 1 distance.
Yeah.
So then at the end,
he's explaining it very.
Computed the distance from you to all the nodes, or at least all the nodes that are in the same component.
Yeah.
If C didn't orbit B, you can still have this setup, and there's just no way to get from B to C. And then
if they were
I
disconnected.
think in the input, probably everything was connected.
Yeah.
Anyway, it doesn't
Yeah.
matter. So anyway, we computed the distance between you and everything in our component.
Yeah.
And now we just need the distance to Santa, and the answer is going to be that minus 2 because they
Which he did in his head.
You and Santa. Yeah, so that's part 2, and then part 1 was just part 1, you comment this line, and then you run this code, and fx just computes the sum of the subtree sizes. This is a nice way of just, if a node has no children, then you don't get an error, you get no children. So count the child itself, and then count the child's subtree.
Yeah.
Probably would have been nicer to have this return 1 for a leaf, and then 1 this plus 1, but whatever, it's not too important, and part 1, just add up the sizes of all the subtrees. So that's basics.
Nice.
Well played, John.
Yeah.
Nathan.
Whew.
Yeah, that was intense.
So I think there was a really good point there, though, that you made as he was talking. He knew he wanted to do a breadth-first search from the moment he read that, because he knew about trees.
Yeah.
And breadth-first search was actually the answer that would get you to it.
Yeah.
I don't think either of us necessarily solved it in a breadth-first way. We just thought about
first principles.
Yeah.
He's not solved that, but when you listen to him talk about it, he's read the problem and gone,
that's a breadth-first search.
That's a breadth-first search of a graph. And because he was using all the terminology.
Vertex was a good word, yeah.
And then he's turned the problem into a breadth-first search problem, which he's got a cookie-cutter solution to in his brain. And then
using the DQ.
Using the DQ. That's, to me, that's not something a normal person just whips out like that. That's something you know how to do, and he's gone, bosh, I'm going to do that. Yeah. And then once he's done that, he's then home and home. So he's taken the problem, turned the input to make it into a breadth-first search graph problem, then smashed out his breadth-first search graph solution, which is just sort of vaguely in his brain, and then subtracted 2 in his mind.
Yeah, because he knew it said explicitly ignore those bits, so he said that.
I feel that's a little bit unfair on him, because I feel like some of that solution is probably not cookie-cutter breadth-first search. Like maybe the bit where he's storing the lengths, or maybe it is. I don't know.
Yeah,
I don't know. It
was a good one. I mean, that's definitely a step above.
Yeah,
because he quickly identified breadth first search and went for it, and I hadn't even considered that was what it was.
I think lots of this is impressive, but I keep saying it. The speed at which he reads the problem, and then correctly solves it without making too many mistakes. On 6, he made some comprehension mistakes. On that, he made none.
Yeah.
And it's like
that was a long question as well.
Yeah, we will have both read that for longer than the length of that video, no doubt. And then made more of a meal of coding it as well. It's just it's nuts.